Alright, hey guys, GreekGamer34 here. So we're back after a long-awaited tutorial on what we're going to do next with this thing. So we need to build a program counter, and to do that, I want to get a color. What color are we going to use here? Let's do, I don't think, have we used green for anything? Let's grab it back up just in case we have. Yeah, we use green for the registers actually, so yeah, we're going to use this color. It's kind of weird color. Alright, anyway, so my thinking here is these three, or this set of 3 bits and this set of 3 bits, when being made into the immediate, has to reach up here, which means the PC really can't be in the way of the busing there. So what I'm gonna do for safety is I'm gonna go right here, like so, and we're gonna be over here somewhere, just away, and then we can move it in as we need to. Alright, so the way I build my PCs is I use T flip-flop based ones. I don't do the adder based ones because I never use relative branching. I always do absolute. I find it's easy and simple CPUs just to use absolute branching. Whoops. So what we're gonna do is we need to make a monostable, so I need a redstone torch. Okay. So this is going to make a pulse. So what this does is, if we do this and we give it a lever, the state doesn't change on the output. If we do this, we have a 1-tick pulse. A 1-tick pulse can be extended into a 2-tick pulse like this. Actually, it can't when it's an off pulse like this. So that's a 1-tick pulse that can't make it through, but it can make it through a 1-tick repeater. Like that. But it can't make it through a 2-tick repeater. So what we actually need though is we need 2 ticks. So the way you can think of this is it's subtracting. This is 1 minus 1, so we have a 0-tick difference. This is going to be 2 minus 1, so we have a 1-tick difference. And this is going to be 3 minus 1, so we have a 2-tick difference. So now if we go like this, we have a 2-tick off pulse. Cool. So now that I've explained how monostable works for way too long, we'll move into the actual PC. So, shoot, I actually want the PC output to be this way, so we're going to move this around, do it like this, here. I'm just going to move it in, and we'll do boop, 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 like that. Alright, cool, so we replicated. So we're going to do that. We need one more tick here. We're going to go here, 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 and oops, there. Okay. So now we need to make a... Oh, first I want to show you that this is T flip-flop. So if we toggle this right here, on, off, cool. So now we're going to put a torch here on the output like that. And then what we're going to do is we're going to come over here. And this is how we're going to be able to branch into this thing if we want. We need to be able to disable. Yeah, we need to be able to disable like this. And we need to use some slabs here when we stack upwards. Like so. And then one other thing we need to do is we need to put a slab here, here, and here. And now what we're going to do is we're just going to stack, we're going to click from the top here to right here. And we're going to, do I want the bits to go up or down? I guess we'll go up. So let's stack. We have 6 immediate, so we need 5 of these because we already built one. Oh, then it looks like our redstone didn't stack, so all we have to do is do this. And then one last thing we have to do is, which I didn't include in the stack, was place blocks. Whoops. Gotta place blocks here. Like that, but this one doesn't matter. Like so. Okay. Okay. So now we have a program counter where it's synchronous. And it will count up for 8 bits. Now we just need a way to get a branching input into it. Which we go like this. We're not going to put an enable on the branch or anything on this side here. And then you can see that leaky back current. We're going to have to put a repeater on here. Or some other sort of diode. And actually what we might be able to do and get away with here is go like this. And then come down one. Huh. Actually, maybe I'd have to do it like this. And then we'd have like an instant diode. That would work to our advantage here. It's not going to interfere with our signal, and it drops it down. But the issue here is we need our branching inputs to... Oh, actually the branching inputs come from the ISA right here. So if we were to continue on this trend, that's 3... That's 4, that's 5, and that's 6. Ah, screw it. Why the hell not? Alright. So do that. If we don't need it, we get rid of it, right? But, I mean, this will save us from having to use our repeaters way up, and then we can get quicker branching inputs. Okay. So now we don't get any back bleed from the wires, and we have our 6 inputs to our program counter. Okay. 6 inputs to our program counter. We have 6 outputs, but here's the thing. Now we need to be able to enable a branch. So now we need to be able to split the clock between 2 signals. We want to split it between either... So to do a branch, we need to hold the gate open for more than this allows. So to do that, we want to just disable this torch without disabling that repeater, or without enabling that repeater. So to do that, we can do this. And if you see here, now this torch shuts off and the repeater doesn't turn on. So now we can disable the monostable and just control it the way we want to. So what we want to do is say here and here, may have to move some stuff around here, but I might be able to make it fit. Anyway, so we need to OR these lines together here. Oops. And this will be the clock input, which normally you just put a button on. So now we need to say, normally we want it to go through this top one. So we have to put power into it. So yeah, we're going to interfere with our nice configuration here. But if we do this, and this can actually come up one, and that can come up one, so that would work. Cool, okay. So we want to do that. We want a repeater there, and we want a torch here. And now what we want to be able to do is bring this down, bring this down, and then bring this over. So we just want to meet these two lines together. And what we just created is a mux. And this mux will say when one or the other bit, and we basically block that off like that. And then so the way this mux works is it says, I'll give it power. So you see normally it's powering this line, and then when we flip this lever on, it powers the other line instead, where it disables this. So we're in here instead of up there. So all this line does is to switch which input goes where the input goes. So that now allows us to branch. So to do branching, we need to conjoin that input with this here, because this disables these pesky torches from giving inputs to our T flip-flop when we only want our T flip-flop to trigger when our clock triggers, which really just turns it into a D flip-flop. So we're turning our D flip-flop into a T flip-flop into a D flip-flop by enabling it like this. We're able to force data into it when we want it to be filled with that data. Anyway, so now we need to hook this line up here, and to do that, I think I'm gonna we'll just do that. It's off by 1. Oh well. Nothing could be perfect. Alright, and then to make sure signal reaches, we're going to go like this. And then to test, signal reaches. Alright, so does signal reach from here? Yep, okay. So now what we wanted, if we wanted to do, so yeah, now if we want to do something, when we flip this lever and there's no input, it doesn't clock or anything. It doesn't update the state. Only when there's an input here does it update the state. So what I'm going to do is I'm going to put a button here. Oops. That. And so we're outputting 4 right now. So if I clock it, we're at 5. Clocked again, we're at 6. Okay. So here's my inputs. If I input, it's going to order that together. So that's going to be like 30, 24 or something like that. 16 plus 8, yeah. So now if I say branch and then update, it goes straight to those bits there. Now if I stop branching and have those bits still there, it should still work. Theoretically it should still work. Those inputs shouldn't mess it up in any sort of way. But it's possible they might when it goes to roll over, so we'll see soon here in 3 more button clicks. 1, 2, 3. Alright, let's see if this needs any more logic. Yeah, we do. Okay. So what if we were to put a bit here and update it? Yeah. So it didn't clear the top bit when we branched, even though there's no top bit here. That's why we needed that second circuit that extends that delay. But we're going to need logic on our CPU that says when to send out that branch. So we'll have an enable in the front here too. Okay. I don't want our ROM to sit so low because I want to make this busing easier to do. So to make this busing easier to do, we're going to have to move this up, which just changes having to do this. But this is uniform, and the busing that we're going to have to do past this point is not going to be uniform. So we want to have to do as little bit of busing here as possible to maximize our efficiency without needing repeaters and stuff, because we're going to have minimal space Whereas here we have a little bit more space, so we're gonna work with this. So what we had before was just these bits of yellow coming across like this, right? So here we're just gonna keep coming up one, and then over. Whoops, shit. We're gonna do that. But over here, instead of being up, we're gonna come down and then over like that. Oops. No, it's just. How did I have this? Maybe it was like this. Oh. This is like this. My bad. There we go. Okay. So we're basically just going to build these up all to the same height like this. And then we have to do this one here, which stays low and then comes up. Okay. And we line them up with redstone. And now we can do position 1. Or no, we'll do a little bit more accurately. Do position 1 here. Do position 2. I'll do it like this actually. Position 2. Copy. And it would need to be pasted here. -A. Cool. Then what we do with this leftover bit is we erase it. And then we do position 1, position 2, / what is this? We want the blue stuff, we want to replace 251.4 with 251.11. 4 with 251. There we go. Okay. Now we can paste it here. Oh no. Yeah, oh yeah, that'll work. Paste -A. I don't know, / undo. I need to do it from like there. Okay. And then we need, so 1, 2, 3, 4, that's good. Then right here, position 1. Position 2, this is a lime green color. It's 251.5. Nice. Okay, and then now we have to do this. And then we'll be here. And then we want to make this one red, which is 14. And And then we need, oh, screw it, I'll just build this one by hand. I don't know, I got rid of that block. Okay, anyway. Come on. Come on. Alright, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so 16 bits of instruction set. These last three have to be, so position 1, position 2. We want that bright blue, that's 251.3. Cool. Okay. So now what we want to do is we're going to select, I don't know, position 1, position 2, and we'll do it like this. Copy, paste, minus A. Oh, that, how did, what? Copy, paste minus A, there we go, okay. That worked. That actually might be perfect right there. Okay. That'll do. That'll do just fine. Let's count the blocks here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 is there, 15 is there, 15 is there. So that means oops. That should work. And if we do this, and if we do this, just to check more than one. Make sure signal gets to here. Nice. Okay, I think that's what we're going to do. So we have 15, well, we have 16 bits that were stacked 15 high here. And then now we can move our PC up and not have to worry about it down here. So what we're going to do is we're going to do position 1. Position 2. I'm going to cut. I'm going to paste here without air. Okay. Well, huh. Do we really want it that high? I mean, yeah, screw it. Yeah, that'll work. That'll work out fine. Alright. So that's going to stay right there. Actually, it's going to be lowered by 1. It needs to be lowered by 2 blocks. So I'm actually going to stand right here. So undo. There we go. Now this should line up with this. Okay, good. Alright, this is going to make all of this busing much easier if everything lines up like that. This is actually going to work out quite nice for doing that immediate stuff. Okay, so what are we going to do next? Let me figure that out. Okay, well, the next thing here that we're going to do is we're going to make everything look like this here. So what I mean by that is now we're going to come over here with a different color. Like this. The reason we're going to do this is now we're going to add where our ROM is going to be put. Okay. One more thing we want to do is go like this. Let's stack, I don't know, 4 or so, just get them out there. Okay, so we're going to go back to our gray busing color. I don't know why, but that's what I've chosen for this series. It's going to come across like this. Alright. Okay, so now we're going to put a repeater here, and we're going to put a power source behind just to see how far it'll reach. And we know it's not going to make it all the way. So what this means is if we put a torch here, and this line turns off, and we had to put a torch here. Oops. Let me do that. Okay. You'll notice this one turns on 1 tick before that one. Ready? So what we're going to do to compensate that is we're going to add a tick to each one of these here. Like that. All the way up until where that repeater is. And then these ones don't have the tick. So now when you read data, it's synchronous. That's how we're going to provide synchronicity here. Then what we're going to do is place 2 lines like this. And then we're going to go from here to, I guess, here. And I'll do stack 3. Lag. There we go. Okay. So that's what 4 bits of our ROM is going to look like. And actually, maybe to spruce it up, we could do this. I wonder how this would look if we did it like this. The colors just help so you know what part of the program you're currently coding for, because you know what colors control what parts of the instruction. But some instructions blend some of these bits together, so it makes it harder to understand what's going on. Like the load immediate blends some bits, like the first 6. Actually, I like that pattern, so I'll do that. Cool. So now we know that our ROM will reach and code our CPU when it starts calling for code. Like the data will make it there. And this lag here between here and getting to the instruction decoder does not matter, as long as that lag is equal across all the bits. Because that input lag doesn't really matter, because it's the clock cycle time that matters to how many instructions can we do. And since this isn't data critical path, it doesn't really matter the delay here, although faster would be nicer, so we're going to try to maximize it still. So now we have a nice amount of room here. And so what I want to do is I want to get these, so not all of these inputs here have to go down. Some of them actually have to stay up, but others have to go down. Like for instance, these yellow ones had to go down. These green and red ones have to go down because they make it down there, but this green and red ones also have to come up a little bit. So because they have to go down, I think the easiest thing we're going to be able to do here is hook up our registers to their respective decoder here, and then over there do the same thing. So let's start by doing that. So first we're going to do our writing instruction, and so this is our most significant bit for our write. So we're going to take this here. Oh, a fly just flew into my face. Okay, so we're going to take this here. We know that our instruction, or that we'll be able to make it to this point here. We'll extend it because we're going to try to optimize it. And then we need to make this come over like this. Oops. And like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Alright, so it's gonna make it to here. And once it makes it there, we need that to extend it across all those. And we're good. Okay, so now we got to do the same thing for all of these. So because all of these are able to make it over here like this, okay, and then we'll do this one, and bring this one all the way down. Like that. Cool. And I kind of like this staggered look here. Oh, actually, no, I don't. Never mind. I'm going to make this one conform. And actually, what I'm going to do is I'm going to bring them all like this. So I want total conformity. Actually, no, I want to bring them all as inwards as possible here, but while maintaining a nice sleek edge. Okay, so sorry. I'm going to go like that instead. That would be my final fix. And then we need repeater here, here. Oh, actually I can move that in. Okay, my bad. Connect them up, like so. Then we got to put our repeaters in up here. So the write bits, so what's nice about this instruction set, if we look at it, the write bits, except for this instruction for the branch, are only really used to do writing. So minimal delay gets to these. It's literally just comes in and goes straight to here. There's going to be one time where we're going to have to disable the output here. And we're going to have to do that here, where certain things we're not going to want to write registers to, and so we're going to need that there for later purposes. Okay. So now we will do our read registers, and so this is our least significant bit here, and this is our least significant bit here, so it looks like we could just take this straight across like this. That lines up nicely. Let's take this here. Like so. And then we'll have this line come right here, like so. Okay, so the other thing our read lines are going to have to be used for is as immediates. And so because of that, we're going to put comparators here. And then we're going to put, we need our busing color. We're going to have to do this. Which is similar to what we're going to do over there. Okay, so now we can control that the write comes through and it comes through to these repeaters that we've already placed. So now we just need to do the blue over here. And to do that, we're going to have to do one small modification. And we're going to just turn this like this here, 2, 3. Place redstone like this. And then we're going to do this. And then so now we can pull this blue through like that. And so this is the most significant bit, and so basically we want this is the least significant bit. So the least significant bit comes straight across. This is going to come right there. Oops. Maybe we'll do it like that. I don't know. Alright, we'll do it like that. So then bring this one here. Do it like that. Alright, that works for me. And we should have, yep, we have repeaters in there already. There, so now we have really tight busing in here. We have encoders and decoders built in. This is a decoder to encoder. This is the decoder part. And so now we have a good amount of things hooked up so far. We have our register controllers, we have our writes, and we have our other register read controller. And then we also have our this hooked up too, which does our opcode. And so we're actually going to have to, let's work on that right now. So what we're going to do is we're going to place repeaters here, and then we're going to place, of course we got to use this, we're going to do this. Whoops. Like this. And you just place redstone on top. And then we're going to see how far it actually goes. Like this. And wow, we just got clearance there. So we'll just come up like this. So it's no surprise that we're going to have delay on these bits. We knew that we were going to, like, stacking 15 high, like vertical, you're going to need a repeater. But the other thing we can do is not only power down there, but we can power straight in here. Like this. And so we'll be able to extend our signal, I think without needing any of these, we should be able to extend our signal straight in. So, like this, actually. No need for any of that stuff. We'll do it like this. And then instead of flooding it down here, we'll flood it here. Okay, so you see I didn't connect this one here and it doesn't make it all the way up. But the ones where they're connected up, I'll make it all the way up. You'll see that this one makes it all the way here, but doesn't make it up. Here, it stops working. It stops working right here. These ones work all the way down and up. So all we have to do is switch something like that, and then now we have nice working way to get our opcode in. This is laggy because it's updating the CPU. Okay, so let's move on to something else. Alright, so I'm not fitting 64 program lines here, but I'm going to want more than 16, so I'm going to stack, like, I don't know, screw it, maybe we'll do 32. Let's see what that looks like. So I wanted to start at line 1. I'm going to stack 31 times. Holy cow, that's a lot of ROM. Okay, yeah, screw it. Yeah, I'm okay with this. For some reason, it looks like... There we go, okay. So, now we have 32 lines of ROM. And we want to be able to hook these up in some sort of way. So now we got to build a decoder for these guys. So that's always fun. You guys gotta love decoders by now, right? Oughta love them. Alright, so the easy way to do this here for me is to go like this. No, redstone to redstone. Stack, I don't know, 8. Screw it, we're gonna need a lot. And then position 1 here. Position 2 here, screw it, I'm stacking before we even add other stuff to it. And stack 31, just see what it looks like. Alright, cool. So we don't need this up here anymore. And now we could use this color. And, well, it's actually a decoder, but our decoders... Yeah, no, we're gonna... The decoder seems to match whatever unit we're doing, so we're gonna make our decoder out of this color. So we need... This is gonna be line... or bit 5, bit 4, bit 3, bit 2, bit 1, and bit 0. So we don't need this crap down here. Like this, so we should have 6 bits total. 1, 2, 3, 4, 5, 6. Nice. Stack this like this. Or we're going to stack this shortly. So position 1 here. Do position 2 here, and this is to clear out those, and then we're going to stack 31. Like that. Okay. So now we have 6-bit inputs here. Now we 6 bits. So we know that redstone travels 15 blocks or 4 bits. So basically we're going to have to come over here and actually screw it. Let's code the program, or let's code this first. So basically the easiest way to do this is, since we're starting at 1, this is going to sorry guys, these need to be if you didn't change your positions of your world edit positions, this should be fine. Okay. Alright, so now to make this easy on us, so 32 divided by 2 is going to be 16. And we already have 1, so we're going to have to stack this 15. There we go. Okay, so then we want this pattern here. And we're going to stack here, position 2, and if we stack that last one 15, we're going to stack this one 7. So let's check. We have 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0. Good. And now we want we have 4, 5, 6, 7, 8. So we're going to take it from here to here. We're going to stack, instead of 4, we're going to stack 3. So we already have 1. And then we have to do the 8, so we have 7 here. Oh shoot, slash undo, and messed it up. There we go. Now we can stack 3. So 7 is going to be 8, 9, 10, 11, 12, 13, 14, 15. Then it rolls up to 16 here. So it's going to be 16. So let's see here. This is so let's see what we got so far. We have 1, 2, 3, 4, 5, 6, 7, 8. Oh, we're missing 8, 9, 10, 11. This should be 12. So it should be like this. Which is 13, 14, 15. 16, 17, 18, 19. Good. 20, 21. This is 22. This should be 23. Good. And then 16 plus 4 here. Or, sorry, 16 plus 8. This should be set to 0. There's 16, and this should be 8. That should be 24. And then now we have 24. 1, 2, 3, 4, 5, 6, 7. Oh, I messed this up when I stacked it pretty good, huh? I may have done more harm than good by stacking it like that. Alright, anyway. So this is 25. This will be 26. This will be 27. And this will be 28. 29. 30, and this should be 31, all ones. Unless that's all ones, so yeah, okay. So this will be 32, which you can't represent with 5 bits, you need 6. And then this becomes here. Okay. The entire ROM is coded. Or not ROM, decoder. The entire decoder is coded. I hope so. I hope that there isn't any missing. Well, we'll figure it out as we start incrementing through it. But now we want to find the 16s, where the 16 turns on. 16 is turns on here, which means this is the halfway mark. Which means we could go like... We can basically split this like this. And then so if we split that like that, you'll notice that the halfway mark here is where the 8s turn on. It's right here. So if this is the halfway mark, and what we're going to do to synchronize this so we're going to go like this. Then repeater here, and now hopefully when you power into these repeaters, the signal reaches. Oh, we're off by 2 blocks. Oh well, we don't really care actually about. Yeah, it's not supposed to reach here, but as long as it reaches here, which it does, we're good. Okay, and then this reaches all the way to here. We're good. Okay, that's perfect. So now that that's like that, we're going to find the 8s here. 8s right here. Okay. So now that we have our inputs like that, all we have to do is now tie these together with those ones over there. So to do that, we're just going to select here. We're going to place redstone on all of these. Select here, and we know that this is 16 blocks long, and we know that one's 16 blocks long, so that's 32 plus 1 is 33, so we're going to stack 33 times. And oh, we overshot. Undo. Guess we only have to do 32 times. Okay, that works for me. Okay, so now we're powering into our ROM like that, and now the easier way to do it, to keep it synced, is to repeat the staggering pattern, the fan out process. Like this. Okay. And then so now if we were to say turn on this bit here, like that, it reaches across. Oh, we're close. We are close. Alright. So we do that, now we just got to get it one extra bit. Okay, so it looks like, wow. Alright, this is going to be a mess, it looks like. If we do this, will that work? Okay. So we're going to put blocks here like this. We're going to do the same thing over here. Like that. Okay, I'm going to go like this. Oops. Okay. So this is how it's going to be. This is how it's got to be actually. Otherwise it won't reach and it won't be synchronous. And if you don't care about synchronicity, then you don't have to do this. But I'd kind of like to have the least amount of problems with this thing as possible for building a CPU in Minecraft. You know, I try not to build the most complicated stuff, but this is still pretty complicated for being a stupid simple CPU. Okay. Anyway, let's turn on some bits, see what happens. Okay, we're able to reach, and the whole top thing is turned on. It only takes 2 ticks to get through, and then 1 tick to get through the decoder, so 3 ticks, but then again, none of this is critical path, so it doesn't matter. So now it's time for this to be brought there. So first off, the easiest way to do drop down is to do it like this. So you come up underneath. You do it like this, and it's going to look like we're going up, but we're not. We're going to do drop down. And this drop down is going to allow us to make it really stackable. But it's going to be super, it's going to be half steps instead of 1 steps. So like up 1 over 1, this is going to be up 1 over 2 kind of a deal. Which is kind of crappy, but it stacks and it's going to look pretty, and it allows us to put repeaters on it if we need to, so I guess that's kind of what we're looking for. Oh, this should probably turn the busing color. we're gonna reach? Yeah, we'll be fine. Plenty far away still. Oops. Oops. Is there one more? Oh wait, nope, that should be good. Yeah, okay. So now we bring this straight across like this. Okay. So now what we do is we select here. We select here. And we do stack 5. Nice. Now we select here. And then we select here. And I'm going to get rid of that just for now. And we're going to stack 5 also. Whoa, no. What was I thinking? What was I thinking? What was I thinking? What we're going to do is we're going to copy here. I'm going to paste -a here. Okay. Oh. I didn't even paste it. Shoot. Come on. Come on. There we go. 2 more. 1 more. And this is what I mean by you can paste it. Or you can stack it. They layer right on top of each other like that. And the signal is able to work its way down like that. So we have ourselves a successful elevation change like that. Where now that's able to decode to the right values if it were to reach all the way, which will add signal strength and all that jazz later. But ideally, these should all reach to the same point, which is right here. So, I mean, screw it, we can do it now. Oh, and that's super obnoxious. Okay, but we'll do it. We'll do it. There we go. Okay, ROM is hooked up with our program counter and a decoder. Okay, guys. So what I want to do now is I want to combine the inputs here to our program counter, which they should probably be done with this color busing. I'm going to we're going to move them in 1 block like this. Like this. And then we're going to bring that, let's see, how close can we get this to CPU? We'll bring it in 2 like this. Place redstone. Bring this across. And that ties in right there nicely. Okay. And then we're going to select here to here, and we're going to stack 5 like that. We're going to fill this in here. Alright, and so now you'll be wondering, why does this line go into the ALU and also into the program counter? Well, this is going to be our immediate line, or this is going to be the line where we say, alright, this value is an immediate, and then over here we're going to say, no, this value is a branch. So what we're going to have to do is we're going to have to figure out where our inputs are going to come into there, and then we're going to have to put a mux on them, like before. So basically just, we're going to have to put some comparators on it. And so the way that I'm going to do this is, this happens to be in the way right here, so I'm going to come right here. Like this. Actually, I might be able to get away with doing something like this. So I'm going to do that. And then I'll do this. Get rid of that. Okay. Cool. So now we got to do that. Well, not that particular shape, but we got to bring this over and up into each. I want to have 3, and then we can bring it down from there. Now what's nice about the spiral shape is if we have to go upwards, we can do the same thing. We can stack it upwards. So we went 3 out, and then we're going 1 down, or going down until we meet there. I guess screw it, we'll use the same color, red. We'll just stick with whatever color is on the ISA. So now we're just able to continue to spiral up like this. Because it's not going to make it if we were to just do that, you see. So we've got to come like that. And then this one, do the same thing. 2, 3, and go down. It's not going to reach, it looks like. So all I'm going to do is come over one, and we'll join it up like that. Or I could say screw it, and we could just, yeah, I think I'm going to do that, because I don't like how uneven that would become. I might screw up some of the green busing. There we go. Alright, let's add some redstone. And what's nice is we can still get buses in here so far for our user inputs, but if not, we can get them over somewhere else. So we'll worry about those later still. User inputs are less important than getting the actual CPU instructions to get fed in properly. At least that's what I think. So now what I want to do is test how or where we're going to have to place repeaters and comparators for muxes. So we're going to put torches like that, and then we're going to allow them to read. And we're going to see immediately that that doesn't reach. Okay. Alright, so now we see how far stuff comes. And what I think is the best bet is to place a repeater like that. So we're going to do one. That's shifted over by one. That's weird. Oh. I mean, I guess that explains why we're off by one. Alright, yeah, let's do that. Okay. So it looks like we could put comparators. Well, we're going to need a set of repeaters anyway, because that's not going to reach. So we can put our repeaters like this. And then we can place comparators here. And this will allow us to decide if we wanted to use that as a branch input or not. We're going to basically use those as AND gates. And we'll hook them up now. Basically just put a torch like this, or a repeater, sorry. And then we just basically stack this upwards like this. Whoops. We want it to stack like this. We're going to place that there to block it off from interfering. And then here, we're going to come over like that. We'll come up one with this. Like that. And all will be good. Okay. I guess these diodes don't really matter because we have our repeaters there and we got these comparators, but oh well, looks cool. I'm gonna keep it there. And then, so we know all of our signal strength makes it through here. Well, actually, now all of it is making it through. Well, not this one here. Oh, well, because I didn't place any. I didn't place any repeaters. Okay. And now we need to come over here and prevent these from becoming real inputs all the time. And so we do that by being lazy and stacking this down 5 times. Don't accidentally type 50 or 55 or something stupid. We've all been there, done it though. pretty laggy just placing blocks. And this is why I wanted that one extra block just in case. And then now we can do that. Oh shoot, but we're still shoot. Alright, so what we're gonna do is we're gonna move. And then we gotta get a busing color. And a repeater. Whoops. Nope. Alright. And then now, if we're lucky, all of these should be on. And then this, we're going to go like this, I guess. Okay, so we should have 6 bits on here, and we do. And we should have 6 bits on over here, and we do. Okay, so our immediate reach, and then now we can just, in our instruction set, when the instruction is called, we'll determine which one of these, which way we want it to go. And power that on, stop reading that, and then we'll get rid of these torches that are off. Okay, so I think that's probably enough for this tutorial. We have come a long way. Look how much more is on the CPU already. It's starting to look like an actual CPU now. We've got stuff hooked up. So coming up in the next tutorial, well, I guess I'll show you what it's going to start to look like. So I'm playing around with screen placement and stuff like that, and clearances. And so I'm thinking of a screen there, and then maybe 3 sets of 7 segs here with a double dabble decoder on the back. Maybe not. Maybe I don't know how I like this layout. How about you guys tell me what you think of this layout in the comments? And anyway, we went from something that looked like that to something that now looks like this. And I'm really digging these spirals. Spiral staircases, they're kind of nice. They're not the best interlocking ones. I know you can make better interlocking ones that aren't offset by one like this, but I didn't care. I just wanted to build them quick and get them out of the way, and it looks good enough. So, yeah, I'll see you guys in the next tutorial. Hopefully you guys are following along. If not, you'll have a schematic out at the next tutorial. Peace.